Hello, everybody. Thank you for coming to the Kotlin Tel Aviv meetup. I'm Alex. I'm developing for around 10 years now. I started doing web first, 3 years, 3.5. Then I switched to mobile, to Android when the first device was available to buy it on Android 1.6, I think, and the HTC Hero. And then I started working in a company. I made an app on my time. Then with that app, I could enter in a company that was the first in Brussels, in Belgium, to develop mobile apps. And I started working there, first on iOS, because there was no Android market. And but afterwards, after a year, I started on Android, and since then, that's what I'm doing. Now I work at MyHeritage. MyHeritage is a company that has a product of genealogy. You can build your family tree there, find people in other trees, etc., and you grow your family tree that way. About the group first. A few words about Kotlin Tel Aviv. We're here to learn together. That's all. We meet once a month. This is the 6th or 7th meetup, I think, already. I didn't count either. But we're saying everybody here is a beginner in Kotlin. It mainly started like 6 months when, for me as an Android developer, when Google made the Android main language on the platform. And the idea here is for you to come and present to the group what you liked about the language. Whatever subject that is around the language, you're always welcome to come and to present here. We got some kind of an issue. We didn't have one woman yet presenting here. It's really annoying to me. So if you know someone or yourself, regardless of gender, want to present, you're more than welcome. The agenda today, we're going to start by a quick history. What is Kotlin? Why Kotlin? For who? So then we'll talk about variables, function and extension functions, what they are, about class and properties, and lambdas and collections. This is a few subjects that I chose as introduction. The subject is bigger than that, and there's of course not enough time to talk about everything. So I'm going to put some points here and there, and you'll have the slides available after the meetup also, and you'll be able to look around and explore more. So what is Kotlin? Kotlin is a programming language developed by JetBrains, the company that develops IntelliJ, so tools for developers. It was open source in 2011 already, but Kotlin 1.0 was out on February 2016. So this is for 5 years they worked on it, and they released it only on 2016, like a year ago. And a big point for Java developers, for JVM developers, Android backend, is it's 100% interoperable with Java. I would put an asterisk on it. There's a few cases here and there that are good to know, but you can basically work with Kotlin and Java in parallel. You can write a class in Kotlin, a class in Java, a main function in Java or Kotlin, and call both. So as I said in Google I/O, a big Google event in 2017, this year, the language became first-class citizen for Android, meaning they doubled the team of Android developers. They're investing a lot on Kotlin, and they said there's a lot of videos you can look online about. It's called Coffee with a Developer, with a Googler, and it's about how they started with Kotlin. So they just started, adopted it, and said to the other developer, "Hey, you should look at that. It's great. It's cool." And he looked and was convinced, and it spread inside Google. They kept it really well secret, and everybody was, the community in Android really wanted it to be adopted because it's already available and everything and stable. And the fact that it exploded. So the language is concise, safe, interoperable, and we're going to see why in the next slides. So about conciseness. So if you have a Java class, I don't know if you can see, I don't know if I can zoom here. Basically, it's a POJO, plain old Java object, with the classic attributes, constructor, getter, setter, two string methods, equals, hashcode, all the good stuff we need to maintain all the time. So if you write that in Kotlin, you get this. You get one class, thank you. You get one class, you define properties. We see why properties, and we don't talk about attribute anymore, attribute or getter setters. They are, in this case, mutable. You're going to see that we can have them immutable, or more correctly, read-only. Define a class person. And the fact that you have data says to the compiler to generate all those functions that we saw before. The toString, equals, hashcode, and a few more. Clone to copy, or copy. Why Kotlin? Why should we look at it? Why should we do that? Yes? So, okay, so the question is, what if I need to implement one of the functions that are generated? So you can still implement it, and it will override what would have been generated. It doesn't need to generate it anymore. So why Kotlin? So basically, it costs nothing to adopt, because you're adding a library that comes with a lot of helper functions called extension functions. And that's the cost of it is just to enter a plugin that is, the library is like a little bit less than a mega, so it's not that big. As I said, you saw previously it's a concise language. It's made to write less and less boilerplate like we have in Java. Because it's a library that adds just functions on existing stuff, you don't have an override. There's no VM on the VM, virtual machine on the Java virtual machine. It just runs on the virtual machine itself. And in Java, we have a problem called the nullability problem. We'll see how we solve that also. And plus, added to that, we have a lot of modern language features that we don't have on Java on Android. So for who? As I said, Android developers, myself, and first, who's here from the Android world? Backend? Okay, much more backend. I should stop talking about Android then. And JavaScript? Okay. iOS? Good. We need to talk afterwards. And JavaScript also. Now I'm looking for people to present and to help maintain the group. And those subjects, we didn't talk about them at all. And I would really appreciate if you would like to do that. So as I said, Android developers with the JVM, backend developers also on JVM. So Spring, Spring Boot, I think, Play, all those frameworks work with Kotlin. For S developers, we have compilation on through LLVM. Windows developers also, same, both go to native. And JavaScript developers, it compiles to JavaScript. So the introduction itself. First, packages and files. Where do we write Kotlin code in a project? So we have usually the Java folder with the source and packages and Java files inside packages. Yes. So the question is, if in JavaScript, if Kotlin used in JavaScript can compile to backend and frontend. The answer is yes. So packages and files, where do we write them? So we can do the same as Java. We keep the same conventions as Java, meaning package name, a class file for every class, but we can actually, we're not obligated to do so. We can have a file with many functions, many classes, and we can also have something that we don't have in Java, a file without a class. We can have functions that can be on the root level, it's called, and we don't define a class in that case. So we can show one big script with everything, but of course it's not advised. It's better to keep the standard, the organization of Java project, just so it's easy to switch between one and the other. So here, if you look at a small project, we have a Java hierarchy, and we have a Kotlin one. Here we have a class, C for class, and the logo of Kotlin for a person. Here we have a class that has no, a file, sorry, that has no class. So you just see the extension KT for Kotlin. Here the same. So let's start with variables. So first we have val, which is value. Like it's a read-only variable, a constant, right? Thank you. So if we declare first name, we're going to write the name of the variable, the value, sorry, the constant, let's say, colon the type equals the value. So here we define a string with the value recal. We can actually omit the type. The compiler is smart enough to understand that the val here is of type string because we're assigning a string to it. It's called inference. The compiler infers the type following the code. So if I, because I said it's read-only, if I try to assign something else, Alex, to this constant, to this value, I will get an error, a compilation error. Actually, val is translated to a final, like if it's a string, it's going to be a final string in Java. So that's for val. Now we have var, which is a mutable one. Var, for same here, the type goes after the name of the variable, equals the value. We can again omit and use inference to not have to define the type. And because it's mutable, we can assign another value to it. But because Kotlin is actually a statically compiled language like Java, we cannot just assign whatever, like in Groovy or dynamic languages. We still have a compiler, we still have a runtime, so we will have an error that int is not of type string here. By the way, we don't have to use inference. If it's clearer for your code, you can just leave it. But in those cases, for instance, it's quite trivial to understand that they're strings. So how do we instantiate objects? Same. We define a val with a type equals some objects. You know that here there's no new keyword. We don't need that. And we call functions as usual. And here we're going to use a println. Println here is a shortcut to system out println, the classic print Java function. So function and extension functions. So first, let's write a maximum function taking in parameters two values, first and second. So we first start with the keyword fun, because I have to do the joke. It's fun to write functions in Kotlin, and same as declaring variables, we put the name first, colon, and the type. Second parameter is the same, defined the same way. Then with colon, we define the return type here. We open the function, and we have the block code inside, like any Java function. So in Kotlin, if and other statements in Java are actually expressions. So if you see before, we had an if, and if one is bigger than the other, we return it, else we return the other one. But because if is an expression itself, we can actually use its value and return only once, and return a value. If first is second, this will return first, else second. We can have default values in Kotlin, something that I really miss in Java. And that means here that we define a default value for first, that is 3, second, that is 4. And we're going to be able to call that and use those default values. If we call it the function maximum like a normal function that we would call in Java, and we can also use the name of the variables to name them in the call. This is useful for a function that have true, 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 false, true, true, true at the end. If you sadly had that in your code base, it's a pain to understand which parameter is which at some point, and this helps because at some point, at the moment you start to use named parameters, you need to name them all, one after the other. So it's really clear to you what are you passing as value to each parameter. Because when we name them, we can reverse the order. Not the smartest thing to do, I guess, but it's possible. And we don't have to define them all. Because we have default values, here we're doing a maximum between 3, I think we defined first, and 8. So we said that the language is concise. Let's use that and see how concise it could be. So first, we talked about the return type. Because the function does only one thing, we're just returning something. That's all. We don't have any other logic. We can actually say, okay, the whole function is just equals to the if expression, like this. So we remove the brackets and we use equals after the return type, and that's it. We don't need to add more brackets anywhere. That's first step to make the code more concise. And then, as we talked about inference, we can actually remove the return type, because the compiler here sees that we're returning an int. So we don't need to say it, we can infer it. And third, the whole 5 lines to just return a value can be shortened to 1 line. So now we have a 1-line function that does exactly the same as the 7 lines function. In those cases, it's quite easy to read, but I would still advise, I didn't put it here, but I would still advise to add the return type. Because if the function is complicated, it's going to be hard to know. You're going to have to read all the function to understand what's going on. Maximum is an easy case, so it's trivial. But to more complicated cases, like in a normal code base, I would still put the return type. So we have a concept, something called when. So we have a for, we have do while, we have while. All that exists like in other languages. But we have something a little bit stronger for switch cases and if expressions, which is called when. So here we're going to have a function that is going to test a value. By the way, any here is the equivalent of object. We're passing something. We're going to talk about the question mark. Thank you. The question mark a little bit further. It's about nullability. So here we're saying to the function, I'm going to send you something that could be null. And we're going to say, okay, if it's the value 3, meaning it's an integer, it's an int, we're going to return value is exactly 3. If the value is an int, meaning anything else, not a value, a type int, we're going to say the double of this value is value multiplied by 2. And here you can see something called string interpolation. And because we used, we already asked the compiler if the value is int. So we don't have to do a casting like in Java. We have smart casting. And here you see it's green. The compiler shows it in green. It means the compiler will infer the type because of the condition. And at this point in the code, it's only an int, potentially. So we don't need to do a casting. We can multiply it by 2. So if the value that we pass is a string, what the f, we're just going to print, we're going to return that it's a switch case with an if statement. And if it's nothing of that, we're not interested in those values. So we're going to just return no value as a string. So you can see here that we combine switches with ifs, if else. So if I have a value of 3, what it's going to print? Okay, simple as that. So because, yeah, I spoiled my next slide. So because we have, again, when is an expression, and we can, you see that we repeat here value every time. And the language wants to be concise. So we can pass value to when, and then we don't need to repeat it. When value is 3, is int, what the fudge or else, we're going to return a value. So so the question is if we can see the differences. We just passed the value word that we wrote on every line to the when between parentheses. So we don't need to repeat it on every case. So the question is, what is the logic of using brackets? Yeah, it's the same as Java. It's to delimit code. So the question is, why are not brackets before the when? You can actually put it, and you don't have to use the equals then. You can write a function like you would write it in Java, just with the way you write it in Kotlin, with a colon, I'm returning a string, opening the brackets, closing, and doing whatever you want in the middle. Here, because when, like if is an expression, not a statement only, it has a return value. And you can use the return value as the value of the function. So that's what happens here. You see equals when, and something happens in the when. Because I have nothing else in the function, so I don't need to embed it in brackets. Extension functions. So usually when we write a lot of code, we want to add functions to existing classes. And we obviously can't, because we're not the authors of those classes. So what do? We write utility methods, static functions that receive a parameter, do something on it, and return something. Extension function is an easy way, is a syntactic sugar around utility methods, where we can write. So here we write also a maximum functions on the class int, so on integer, and we pass another value as parameter. So we're going to do a maximum between ourselves, the value that this function is going to be called on, and I think I should put an example so you understand how we call that. Here we do 3.maximum4, and this will return 4. Yes. So we use the same function as we wrote before in a one line, just passed in 2 lines for the slides, and we can call it on the function itself. How does it work? Under the hood, it's going to be compiled actually to a static function, like we have in Java. And the first parameter will be the int, this one. The second one will be the one we pass. So if we look at the code generated behind this, it's exactly a static function. Yes, a question.
Do we have boxing here of free to int, or is int primitive, or is it an object here?
So types are primitives are types in Kotlin. It's actually a little bit more for developers, for the end users of the language, us. It's just a class. So it is a big int. You don't have a small int. Under the hood, if you don't use anything that is from the class, it's going to be compiled to a small int. So we don't lose performance in that case. In this specific case, I think we don't do anything on the class, so I guess it could be a type, but I would check that. Actually, I think I have the code here. Let me just check. So here I define a function. I just call it maximum2 for sorry, we're going to use this one. This is the definition we're talking about. Let's remove the rest. Not interesting. Not interesting. Up. And then we're going to print and off. We don't need this. We can actually 3.maximum4 up. And then what I want to show here is that actually we have a tool to check all those things. So if you look at tools, Kotlin, and then you look at show Kotlin bytecode, it's going to show us the exact bytecode that this class generates. So Kotlin compiles to bytecode, like Java compiles to bytecode. But of course, this is too difficult to read. So we have a button to decompile here. You can see what's going on. This is the translation of what we wrote in Kotlin to Java. And you can see that maximum is actually, yes, is a small int, because we're not using anything on the class. Yes?
Why did you write other in the slide? You didn't put other when you're calling functions. And in the code you put other.
It's automatically by ID.
No, not here. When you're calling the function before the for.
ID.
Yeah, this is called a hint. It's just hinting what the name is. Actually, I could do. I could name it myself. And then it won't do that. The editor in the last version, since, I don't know, a few months, adds hints like that. So it's easier to read even though you don't have more information about the function yourself. We have another special keyword called infix. If we wrote the same function, the same extension function with the infix keyword in front, we can actually do the following. We don't need the dot, we don't need the bracket, the parenthesis, and we can do 3, maximum 4. Why is that useful? In this case, it doesn't show up, but it's useful to generate, to create a DSLs, data-specific languages, where you can chain, you can suddenly use words. You can give the impression that your DSL brings keywords to the language. You're writing a language by writing functions. One more thing on those cases, because I had a question in a previous meetup. First and second are here read-only variable values. So you can't, in Java we have a parameter, let's say I have a string or first. In Java I could assign another value at first. Like the first line would be first equals 10. In Kotlin you can't do that. Null safety. Ready for that? Cool. So the problem itself, we're going to say we have a string that is, in this case, not null. So let's say some time advances in your program, and at some point the value becomes null. And now you're testing it. You run some coordinate, and what happens here? It's going to crash. Yeah, null pointer exception. The classic error we have. 80% of our crashes in our app are null pointer exceptions. Even though we really try to do defensive programming and comparing all the time to null, it always passes our grid or tests and our code reviews and crashes at some point. So we have a nullable type. You saw that previously also. So here we declare a value A of type string that cannot be null in this case. If we wanted it to be null, we would have the question mark after the type, after the class, which makes a nullable type of string. So how do we use that? If we want to be safe, we're going to use a question mark dot on a function. This will actually return true if the string equals other string, and return null in case B is null. So we're going to have two different values here. If we don't care about crashes and we actually want a crash, and it happens when, let's say you have a part of the screen. In Android we have screens, and we send parameters to the screens. Let's say I have a list of people. I click on one of them. I open a screen with the detail of one person. And I don't want to open the screen ever if there's no value, because I don't have anyone to show. I need an ID or something. And in that case, you do want a crash, because you don't want the user to see a screen that is empty. That doesn't make any sense. So safe typing is good, but sometimes you do need the unsafe way of 2 exclamation point. Why 2? You see it looks like it's yelling. Be careful. And this is to show to the developer that here the language explicitly tells you that it potentially can have a crash. So we can actually chain functions, and that on every step that can be null. And this actually compiles to the following in Java. First, it's going to check the first part. It's going to check if it's not null, then check if this part is also not null, and return and call this function on all of it, because we check that both are not null, and else return null. So or I return an integer, or we return null here. But what if we really want to have only an integer or a Boolean value? Yes? So the question here is if the code showed in the slide will actually run twice. And yes, because it's going to need to parse it also first. It's not only about checking the value. So here we get the value, and let's see the compilation. Oh no, you're right. It's made once. Good. If we do want to have whole comparison, so if we have this one, we said it would return 1, or can return null. But what if we want to return a value anyway, a default value, or a condition that is true or false? We have something called the this operator, where we're going to put a question mark column with the default value we want. The case, if it's null, it's going to return that value. So why this operator? Because else. Any question on the null safety? So the question is about primitive types. The interoperability in Java. Java doesn't have that. So what happens is that every type is going to be called a primitive type. Sorry, not a primitive, a system type. And those ones will actually, we're going to have a notation to make a difference. It's the variable, the type with one exclamation point. And that indicates to Kotlin that actually we don't have null safety there. And you can act like it's a nullable type or a not nullable type. And it's up to you, because it comes from Java. So Kotlin doesn't know. I like to mark them as nullable and manage the case. So this is the safest, I think. Yes, another.
Can you go back to the example of the b.sample? So if a b is a nullable, I can't do b dot at all? It won't compile? Exactly. I need to have a...
Yeah. So here in the example, if we have it, so if I try to do this, I actually have an error. So because the type is nullable string, I do have to manage it. I could do the same, I could do like this also. So if I have a variable that is a nullable string, I can use or a question mark to be safe. And if this is null, wait, I'm printing something here. Result, print then result. Oops. Up. I think the best is to try things. So I encourage you to open your laptop and try out those things. So here it's null. If I have a value, it can return me the value, the comparison. And if I do have null and I don't care about it, it's going to crash. It's going to give me a Kotlin null pointer exception. So classes. So we said we had a person with a val first name and now var last name. So the first one, val, is read-only. The var is mutable. So we can change val. We can change last name, but we cannot change first name. This equals to the same thing here. What we have in those parentheses is the primary constructor. And because we don't have any annotation, anything special, we can actually omit it. There are annotations, for instance, if you have default values for each parameter, you can actually tell Kotlin to do a JVM overload, I think, which means it will generate for Java a function with every parameter. The first one, only this one, the second one, the two of them, etc. As much as parameter as we have. That helps to not have those classes where you have 5 constructors, one call each other with another, with null, 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 and etc., etc. This actually also equals to the same thing here. The difference is that we don't define val and var in the constructor. We can actually pass parameters to the constructor and then use them in the code. And as you see, we can also infer the string type for last name, and we didn't do it for first name. And this equals to this in Java. So it is concise. We have, as we saw, first name is val, is final. So we don't have a way to change it. So we will only have a getter for it, because it's final. But last name is not final, it's a normal one that has a get and set. And that's how Kotlin is checking that things are null or not and throwing errors. It generates function inside your functions to check all that. And the constructor itself sets the values. So if we write functions inside the class, it's going to be the same. Here, we create a function getFullName, and we use again the string interpolation where we can write string inside. We don't have to concatenate them with a plus. We can add them like this with a $. If we have a function inside or something, we can put curly braces around it and call functions inside the string. But here I just need first name, space, and last name. So this will return me the full name. And this equals to this function in Java. So something interesting is that we can actually think about functions as properties. A full name is actually a property of someone, of a person. So we don't have to write it as a function. We can write it as a property. So we're going to write val full name, and we're going to define what is get and what is set. For example, here I say, OK, if I have a get, will return me the full name. But if I set the full name, I'm going to actually use the values that I can from that assignment. So here I'm going to say first name. And by the way, for the example, they're both vars. Of course, if not, I couldn't do this. And I do a split on the space in the middle, because I expect that there will be a space. And first name equals to the first one, to the first value of the split, last name for the second one. Yes?
Do you use semicolons? Because in some parts you don't use, and in some parts you use.
Semicolons? Where did I use them?
In some slides there are semicolons.
No, in the Java slides.
Oh, okay.
Those are Javas. In Kotlin, true, nice remark. We don't use semicolon. We don't need it. You can put it. Actually, if I will switch and show you. Here I can use it, but the editor will tell me it's redundant. We don't really need it. The compiler knows to understand an end of line or an end of a call. There's one case where you do use semicolon is when you define enums in a class. Enums are a class in Kotlin. And to separate the values from functions, you do need one. This is the only case that you need semicolon. So what I showed here with the full name as a property translates to getter and setter in Java. Nothing special here. Yes. So the question is, if you don't use your semicolon, how does the compiler knows that? He does know. There's like a part called a parser inside compilers. And they made it smart enough to understand. I guess, yeah, passing on the line, you can. I'm a little bit hurrying up here, so I'll go fast for the next one. Lambdas. Lambdas are a definition. It's called a function type. It's a type that is a function. You probably know that from Java 8 with lambdas. In Android world, besides the libraries that brought that, we didn't have it. So that's one of the things that I really love about the new language on Android is that we finally have lambda. We shorten the code. So here we have a sum of lambda that declares a type in parentheses with the arrow the result type and then the function itself with the parameters. We can define the same this way. We don't need to name the parameters x and y here because the types are matching the functions. And we don't even actually need to write it separately. We can actually say, OK, I have a lambda, x int and y int. And the body of the lambda is x plus y. And this will return a function that can add stuff. So if I have some function, like the first one we saw, it compiles in Java to a class called function. Function and a number of parameters. So every lambda is actually translated to an implementation of a class. So we need to be careful with that. There's ways called inlining where you can actually say to the compiler, OK, if I write a lambda, I don't want to have a class everywhere I use it. I want to copy the body of the class inside your code at multiple points. We're going to see that later. So a little word why lambdas are so cool. Because then we can do things like that. We have a list of 1, 2, 3, 4, and we're going to use the function map on it. the function map is a function that receives a lambda, and it's going to do a mapping between every element. It's going to go through the list, and on every element, it's going to apply what we're going to put in the lambda and return that in the new list. So here, it is the, during the iteration, it is every element, and we're going to add 2 to it. So what is going to be the result here? Exactly. And then, because we get a result as a list, we can actually continue. We're going to filter here. You don't have to use it if you don't want to, because it could be, and I think it's better in some cases. When the lambda is just one lambda, it's okay to use it. If you have multiple lambdas, one inside another, it becomes a mess, and it's better to name the value for each iteration. So here I'm going to say, okay, I want to filter, so I'm going to do a filter on the list. So this is the collection comparator, basically. And for every one of them, I'm going to do a Boolean condition that says, if it's mode 2, 0, if it's pair, keep it. So this is going to filter the list. And then I want to get the first one that is bigger than 5, or null, if there's none. And on every step here, it's going to actually generate a list. So we have sequences to help about it. Yes, a question.
The previous slide, each lambda here is, each lambda here is actually, it's a parameter, and the
yes, exactly.
And it doesn't have places. That's because it's only one.
Yes. The good thing is that we can actually check it, and I think that's the best. Oops. Here. So if you look at map, it's that function. Commit a transformation. Sorry, here I'm already using sequences. Let's use normal filter. And we said first. 5. Okay. So here you can see that it's a inline function, meaning it's going to copy the inside of the function generated inside our code, so we don't have an extra class. And it's just a mapping on this is called a receiver with sorry, what's the name? Lambda with receivers. Lambda with receiver. Oh no, sorry, it's a normal lambda with 2 types, and we're going to map it to another list with a function that we run on it. It's like a callback. And filter is the same. It's also inline function. And actually, the STD, the library that Kotlin adds, it's a lot of those kind of functions. Functions that receive parameters lambdas, and we can use it to do functional programming there.
Yeah, but why don't you have traces then? It's because like if you have only one parameter, then you don't need the traces.
Exactly. Exactly. The lambda needs to be, in that case, the last parameter if you want to be the last or the only one, and then you don't need the parentheses. So if we want to not generate a list on every call of the function, we can use sequences. And sequences will do, instead of doing every function to every line in parallel, and then passing to, let's say, first map, it's going to do a list of the value plus 2 for everyone. Then filter, it's going to filter everyone, and then do a new list. We're going to use a sequence, and it's going to actually do, it's going to first take the first element of the list, add to 2, see if it's a pair, and see if it matches the last one, etc., etc. This will be more performant because first, it doesn't create a list on every step. Second, it's going to stop as soon as it finds one that is bigger than 5. Any questions on anything said here? Yes, one question. Yes, so the question is if we have ranges in Kotlin, we do. We do. So we can do for loops on ranges.
Oh no, I meant like here, for example, can you say from 0 to n dot map dot filter and so on?
Yes, you can cut lists. I don't remember exactly the name of the function, but yes, you do. So some resources to continue the learning path. first, the meetup group. I hope you're subscribed. Second, we do have a Facebook group to talk about points, new articles, whatever we find interesting, blog posts, etc. We're going to have the code that I showed here in GitHub. There's a really nice Slack forum chat with the whole community of Kotlin. You have there a lot of people. You have all JetBrains, and people respond a lot, really fast to questions. There's a lot of channels about async programming, functional programming, etc. You can get a lot of help there. I advise you to have it somewhere on your screens. And if you have a doubt, you have, of course, the documentation, but also you can ask questions. And trykotlinlang.org is a really good website. It's a website to try Kotlin online. You don't have to download anything, not IntelliJ. No, it's a browser inside it's an IDE inside the browser, and we can have a look at it. So there are exercises, and there's things called cones. Actually, exercises with that you can run. You are asked to complete. You have a small question here. You complete the function. You can run it. Where is it? Here to test it. And you see that it compiles because well, we didn't implement here anything. So if we do, it wants us to print OK. So we'll do a run. And you can see that the test compiles. We can go to the next text. And it's really, really nice. This is the first step to start, I would say. The reference, obviously, you can have it in PDF. It's not the easiest to read, but it's really nice. It helps understanding how things are written. And Kotlin.link is actually a collection of a lot of links, blog posts and projects and libraries and everything. It's a really good resource to look at. So thank you for coming to this session.